Hello guys, it's your guy Viera. Welcome back to my new tutorial. Today we are going to be generating the M&G code required for VMS project 11. Looking at the programming, CAMPAD definition, we are using ITEL as our CNC controller coordinate system. We got Mach 1 and Mach 2, Mach 1 as the main spindle and Mach 2 as the back spindle. Stock. We got 0.02 required for the facing, and we got some extra material required for the clamping. Go for the green check. Target. Our target is the cat model. Go for the green check. The setup has equally been done like in the previous tutorial. Looking at the first operation, facing operation for the main spindle. Geometry. We are using this surface or simply this line. Tool. We are using an external tool of angle 80 degrees, making sure that this direction should be selected. Levels or the safety distance. Technology, making sure that you are using front, roughing pass and finishing. Looking at the simulation. Our next operation will be turning operation. Looking at the operation, geometry, we are turning from this chamfer point up to the end. Tool, we are still using our same tool, an external tool of angle 80 degrees. Level, technology, we are using long external with a roughing pass and a finishing pass with compensation on. Strategy, non-descending. Looking at the simulation. Next operation, grooving operation, geometry. Our geometry begins from the starting point of this groove to the ending point of this other groove. Tool, we are using a very small groove tool. Looking at the groove parameter, we got a groove tool of width 0.00394. This can be seen equally here, and we have A of 0.0157. Go for the green check. Our groove direction should be this. Levels or the safety distance technology, we are using long external with a roughing pass and a finish with compensation on. Looking at the simulation. Groove done. However, we still got some raw material or some extra material around the groove. So in order to finish this, we have to use another tool and we have to make a finishing pass. Looking at rest material, so you notice that the groove has not been done properly. Reason being that we have chamfers around the groove. Finishing pass, geometry. Our geometry is still the same groove geometry. Tool, an external tool of angle 35 degrees. Direction, this direction. Levels or fine. Technology, now we are using a descending pass. We are just using directly a finishing pass. Looking at the simulation. Rest material. So as you notice, the groove has been totally machined. Next operation, we have to drill the holes. We are under Mach 1. Tool, we are using 0.31 inch. We actually got two holes. We have a hole of 0.31 that goes through the part. Our first drilling will go through the part, and then we have another hole of 0.42 that doesn't go through the part but goes at a distance of 0.5. So we are under Mach 1, so this direction. Technology, the drilling start, it should be this point, and the drilling end should be this point. Now we use a delta of minus 0.1 inch. The drilling circle should be back. Drilling data. We are using a step down of 0.025. Full diameter activated. Looking at the simulation. Next operation we want to do is tapping that hole. Coordinate system, since this is tapping, we are tapping around the center, so no coordinate system. Tool, we are using the tapping tool, looking at the two parameters. The pitch, in order to achieve the pitch, you just have to take 1 divided by the depth per inch. In our case, the depth per inch over here is 16. So we take 1 divided by 16, that gives us 0.0625. The thread diameter is simply equivalent to 3 divided by 8. Then you go for the green check. Starting drill, the origin, any drill, according to our drawing we have 0.32. Drilling cycle, we have tap. Looking at the simulation. So all the operations on the main spindle has been performed. So we want to perform the operations on the sub spindle. In order to do this, we have to make a path transfer from the main spindle to the sub spindle. This has already been covered in the previous tutorial, the MCO, and we actually use the same method. Firstly, the rotatory, we tell the rotatory to go to home position. Secondly, we have movement, we tell the rotatory to stay at safety position. This is the main two turret, so the main two turret has to rotate. As in the previous tutorial, the main spindle, we tell the main spindle to move at home position. And remember that since the main spindle is holding the path, we use path movement and we do not use movement. Back spindle, so currently we tell the back spindle to go back to home position. We tell the back spindle to move close to the main spindle, and then we tell the back spindle to hold the piece. Clamping, the main spindle unclamps the piece and the back spindle holds it. Since the back spindle is currently holding the piece, we use path move and not movement. So we tell the back spindle to move back to home position. So this was actually covered in the previous tutorial. So we go for the green check. Looking at the back spindle operation, facing, geometry, we have the surface tool. We are using an external tool of 80 degrees, making sure that this should be the direction. Offset, finishing with compensation. Looking at the simulation. The next operation is turning because we want to take care of this chamfer. Geometry. Our geometry is actually this chamfer. Tool. We are still using our same tool, external tool of 80 degrees. We are using a finish pass only. Strategy, non-descending. Looking at the simulation, just perfect. Our next operation will be doing this hole. If we use a drilling tool, the hole will not be properly finished, we will not have a proper surface finish. We will use boring operation to actually complete this hole. Go for the boring, edit, geometry. Our geometry is actually this hole, or simply this line. Tool, we are using an internal turning tool, or we are using a boring tool. This time around, we want to make sure that this should be the direction. Technology, we are using a roughing pass, and since this is a boring operation, or it is an internal operation, you make sure that our mode should be long internal. Roughing, we are using a roughing pass and a finishing pass with compensation on. Strategy, non-descending. Looking at the simulation. So the last operation we want to make is actually our tapping. The hole has been drilled, so we want to make tapping. As coordinate system, we got Mark 2, it should not be Mark 1. Remember that we are working with the back spindle, so Mark 2 should be selected. Tool, looking at the two parameters. So currently we are making tapping for this surface. So our tool diameter should be half, that is 0.5. Equally for the pitch, in order to have this pitch, we just have to make 1 divided by 13. Let me just highlight this. So 1 divided by 13. This gives you exactly the pitch value. Then you go for the green check. Levels or the safety distance. Technology, starting, it should be the start, and the drill end should be 0.32 as per the drawing. Drilling cycle, tapping activated. Looking at the simulation, all fine. So the programming is done. So next thing you want to do is make a channel synchronization. You want to synchronize the main spindle and the sub spindle. In order to do this, you use channel synchronization, making sure that you should be at the top of your operation. Channel synchronization. Just have to save, then simulate. So let's verify. Operation, G code, generate G code. So here is our G code. With this, we are done with VMS project 11. If you have any question regarding this project, do well to contact us by Facebook or by email, or even leaving a comment in the commenting box. Keep liking the video, keep sharing, keep commenting. Thanks a lot guys. See you guys in the next tutorial.